Hey guys, welcome to yet another video on energy, work, and power. Alright, okay, you've got a picture here, snapshot of the Legoland Malaysia Resort, latest VR ride. Alright, what exactly is energy? Let's start off with energy is basically the capacity to do work. SI unit of energy is the joule. Okay, starts with a capital letter J. So what is work, man? Alright, so work basically means just moving a body by using a force. Okay, we'll cover a little bit more of that in the meantime, but I guess this doesn't really help to explain energy, right? So just to nail it in, okay, basically in order to do work, energy is transferred. Okay, so when you change energy from one form to another, you are basically doing work. Okay, so they are related. In fact, they are so related that both of them are actually using the same unit for joules. Okay, all right. So what are forms of energy? Energy is basically what a body has, and a body can actually have two main types of energy, either kinetic or potential energy. We're going to cover both of these types in this chapter. Specifically, for potential energy, we're going to cover gravitational potential energy. Okay, chemical potential energy is basically like a battery, and elastic potential energy is basically like an elastic band. That's just like what the word self-explanatory means. Okay. All right. So there's also other forms of energy like light, thermal energy, also known as heat. Okay. And we also have electrical energy, which will be covered later on in the syllabus, as well as nuclear energy, which is not really in either the N or O level syllabus. Okay. So what do we have here? We got a skate park, a skater and skate park. Okay. So first question, what are some of the physical quantities that you see? You can see the height of the ramp. Okay, the skater is at the different heights of the ramp. Okay, you can see the mass of the skater also, as well as the speed of the skater. You see it varies, right? Okay, it's fastest when it's all the way at the bottom, slowest when it's all the way at the top. Okay, so what remains the same? Remains the same will be the total energy. You can see a total energy bar. Basically, this total energy bar is the sum of the kinetic and potential. So these two bars, the green and the blue, if I add both of them up, I get this total energy. Okay. All right. What changes? So just showed you both the kinetic and the gravitational potential energy will change. So how does it change? Okay. So this relationship, as you can see, first thing, as the height increases, the gravitational potential energy increases also, and kinetic energy falls. Let me just take a snapshot all the way here. Okay, you can see as height increases all the way at the top, gravitational potential energy is highest, the speed is the lowest, almost zero, right? So that's why kinetic energy falls. Okay, so if I continue, okay, try to hit rock bottom. All right. So as the height decreases, you can see gravitational potential energy decrease also, but kinetic energy goes up. What is kinetic energy? Okay, so kinetic energy is actually related to the speed. You can see the speed. Just now it was zero when the skater was all the way high, all the way high up in the ramp. Right now, if it's all the way at the bottom, the speed is actually at a maximum. That's why the kinetic energy is also at a maximum. Okay, so what does all this come to? Okay, it comes to the principle of conservation of energy. Basically states that energy cannot be created or destroyed, can only be converted from one form to the and to another. See, it converts from potential to kinetic, now back to potential again, now converts to kinetic, then to potential, and that's basically what it means. Total energy is the same. I don't create or destroy it, but it's converted. Okay? So just now we were talking about GPE, gravitational potential energy, and kinetic energy. So gravitational potential energy, the variable will be the height. So the higher the skater is, the higher the gravitational potential energy is, right? What about kinetic energy? Kinetic energy will be the faster the speed, the higher the kinetic energy. Okay, so question right now. What is the exact relationship for gravitational potential energy? All right, just gonna introduce this to you. Next, and boom. Okay, the gravitational potential energy formula relationship is mgh. Basically, it means the higher the an object is, the height, the gravitational potential energy is higher also. Okay, what about M and G? Okay, M and G is basically, it will make sense. Why? Because the heavier an object is, the more mass an object is, it will also have higher gravitational potential energy. For example, if you were to drop a bowling ball versus drop a small marble, okay, from the same height, which one you think will cause more damage? Of course, the bowling ball, right? Why? Because it has more mass. Okay, so that's for gravitational potential energy. What about kinetic energy? Okay, we know that it's related by the variable v. That means the speed or velocity. The higher the velocity, you can see, the higher the kinetic energy here. All right. So the relationship will be, now get ready for this, in three, two, one, boom. Okay. Its kinetic energy is equals to half mv squared. Okay, so every time your velocity increases by a little bit, okay, your kinetic energy increases by much more. Okay, what about mass? Why is mass in the equation also? Okay, again, it makes perfect sense because if I were to have a bullet flying at, let's say, 10 meters per second, versus a missile that's moving also towards you at 10 meters per second, which one will you think will have higher kinetic energy? Okay, of course, the missile, right? Because the missile or the bomb will actually have a higher mass. Okay, although the velocity is the same, but because of virtue of the higher mass, it will actually have more kinetic energy. All right. So these are the two main formulas for gravitational potential energy and kinetic energy. Hope you enjoyed this video. All right, I will see you in the next.